Have you ever used something like ChatGPT and just wondered how? How does it do that? It can feel like actual magic, right? Well, today we're going to pull back the curtain and see how these incredible tools really work. Okay, get this. That sentence you're seeing? It sounds pretty poetic, doesn't it? Like something straight out of a sci-fi novel. But an AI wrote that word by word. It just knew that a pie creature would belong in a world of math. So how on earth did it make that leap? What's the secret? And that really gets to the heart of it, doesn't it? Is this thing actually thinking in a way that you and I would recognize? Or is it something else entirely? A super clever, super convincing illusion? Well, let's dig in and find out. All right, so here's the big reveal. The absolute core secret behind all of this mind-bending complexity is actually ridiculously simple. You ready for this? Everything these models do, no matter how clever it seems, boils down to one single repetitive task: guessing the next word. Okay, let's just walk through a super basic example. Imagine we give the AI a little piece of text, a prompt, that says, "The cat sat on the." That's it. Now, the AI's entire job, its only goal in that moment, is to figure out the most probable word that comes next. So what it does is it looks back at basically the entire internet that it's been trained on, and it runs the numbers. It calculates a probability score for every single word in its vocabulary. So for "the cat sat on the mat," mat is probably going to get a super high score. Couch might get a decent score too. But a word like galaxy, that's going to have a probability of pretty much 0. And once it picks the most likely word, let's say it's mat, it just tacks it onto the sentence. Now the prompt is, "The cat sat on the mat," and it does the whole thing over again. What's the next most likely word? And the next. It just keeps doing that over and over. That simple little loop is how you get everything from a one-sentence answer to a whole essay. So this is really the key takeaway. A large language model isn't a brain, it's not thinking, it's a massively complex mathematical function. You put text in one end and out the other comes a ranked list of probabilities for what the next word should be. That's the whole game. Okay, but hold on. If it's all just math, how does a computer, which only gets numbers, understand words like cat or galaxy in the first place? Well, obviously, it has to translate them into its own language, the language of numbers. Yeah, the model can't read the word cat like we do. For the computer, every single word is turned into a long, long list of numbers. We call this a vector. And that vector is basically the word's unique fingerprint, its numerical ID inside the system. This whole process has a name. It's called embedding. And this is where things get really cool. Think of it like this. Imagine a giant invisible, well, it's actually multidimensional, but let's call it a meaning space. Every word is a single point in that space with its own set of coordinates. And here's the magic. Words that mean similar things, like happy and joyful, end up clustered together. They're neighbors in this space. But it gets even crazier. The relationships between these points, the directions and distances, also have meaning. Here's the classic example. The line you could draw from the point for man to the point for king is almost exactly the same in direction and length as the line from woman to queen. The AI wasn't taught about gender or royalty. It figured out these abstract concepts all on its own, just by seeing how words are used together. Okay, so we have words as points in space. Awesome. But there's a problem, right? A word's meaning can totally change depending on the sentence it's in. So a single fixed coordinate for a word just isn't going to cut it. The model has to figure out the context. Just think of the word bank. If I say I sat on the riverbank, that's one thing. If I say I went to the savings bank, that's completely different. The starting vector for the word bank is the same for both. So somehow the model needs to adjust that vector based on the words around it, like river or savings. And the genius solution to this problem is something called the attention mechanism. This was a total game changer. You can basically think of it as a system that lets all the words in a sentence talk to each other. They look around, see who their neighbors are, and share information to figure out the proper context. Here's a simple way to picture it. The word bank sends out a flare, a query, that basically asks, "Hey everyone, what's the vibe here? What kind of sentence am I in?" Then other words in the sentence, like river, hold up a sign, a key, that says, "Over here, I'm about nature and water." The system sees a match between the query and the key, and so river gets to pass its meaning, its value, over to bank, which helps to clarify its meaning. So by the time this whole attention process is done, the number vector for bank isn't just generic anymore. It's been tweaked and updated. It now contains the specific meaning of riverbank. The context is literally baked right into the numbers. Okay, so we have this amazing system for understanding words and context. But how does it know how to do any of this? Nobody sits down and programs the rules of grammar or the relationships between words. The answer is it learns. It teaches itself by reading pretty much everything ever written on the internet. Picture it like this. The AI starts out as this enormous machine with billions of little dials called parameters, all set to random positions. During training, you feed it a sentence but hide the last word. The cat sat on the... It makes a guess. Then you show it the real word, mat. If its guess was wrong, and at first it always is, a clever algorithm called backpropagation goes back and adjusts every single one of those billions of dials, just a tiny, tiny bit, to make it more likely to guess correctly next time. Now just imagine doing that trillions of times. And when I say a lot of data, I mean a mind-blowing amount. To give you some perspective, the text used to train just GPT-3, if you were to sit down and read it all, 24 hours a day, 7 days a week, no breaks, it would take you over 2,600 years. The sheer scale is almost impossible to wrap your head around. And that brings us back to those little dials, the parameters. A model like GPT-3 has 175 billion of them. Every single one of those dials was fine-tuned over and over again during that massive training process. That is what we mean when we say large language model. It's all about that incredible scale. So when you put it all together, you see that this amazing flexible intelligence isn't something we explicitly programmed. It's an emergent property. It literally just emerges from this one simple task, predicting the next word. But when you do it at an absolutely colossal scale with a sophisticated architecture, it builds this unbelievably complex map of the world just by learning the patterns in our language, which leaves us with one heck of a question to think about. If all of this can emerge from something as simple as predicting the next word, what does that say about how our own intelligence works?